It started as a weather alert on your phone, a small notification, easy to ignore. Maybe a yellow warning banner at the bottom of the TV screen during the evening news. For millions of Americans across the Midwest this week, that is exactly how it began. A routine spring storm, nothing unusual. And then the sky turned green. By the time it was over, more than 50 million people had been directly threatened. Over 53 confirmed tornadoes tore through 6 states in a single day. An EF3 twister with 140 mile-per-hour winds obliterated farm after farm in Buffalo County, Wisconsin. Homes in Ringel, Marathon County were demolished, roofs gone, walls collapsed, families sheltering in basements as the world above them came apart. Hailstones the size of softballs and potentially a new Illinois state record rained from the sky near Kankakee. Chicago's O'Hare Airport recorded its highest single-day rainfall since records began. And the National Weather Service in La Crosse issued 26 tornado warnings in a single day, the most in that office's entire history. Welcome. This is the story of the April 2026 Midwest tornado outbreak. What happened, why it happened, what it means, and what is coming next. Because if you think this week was bad, the science says you need to pay. Very close attention to what meteorologists are now saying about the rest of this season. Let us start from the beginning. To understand what happened this week, you need to understand the atmosphere that built up over days, because the April 2026 outbreak did not come from nowhere. It was the result of a perfect collision of atmospheric conditions that meteorologists had been watching with growing concern since April 13th. Beginning on April 13th, an incredibly active stretch of severe weather locked itself into the central United States. The Storm Prediction Center, the federal agency responsible for forecasting severe weather, placed parts of the Midwest under a level 2 or higher severe weather threat on April 13th, 14th, 15th, and again on April 17th. 4 separate severe weather days in less than a week. That is extraordinarily unusual. The basic ingredients were all there and stacking up dangerously. A powerful low-pressure system was dragging warm, moisture-laden air northward from the Gulf of Mexico, air that was unusually humid and unstable for this time of year. Simultaneously, a strong cold front was pushing down from Canada, and a fast-moving jet stream was providing the wind shear, the changing of wind speed and direction with altitude, that is the critical ingredient for rotating thunderstorms called supercells. Supercells are not ordinary thunderstorms. They are the atmosphere's most violent and organized storm systems. They can sustain themselves for hours, travel hundreds of miles, and produce the conditions needed for the most powerful tornadoes on Earth. When Gulf moisture, jet stream energy, and a cold front all collide in the right configuration, supercells do not just form, they explode. On April 14th, Chicago O'Hare recorded 2.43 inches of rain in a single day, a new daily record. Rainfall totals of 4 to 6 inches accumulated across northern Illinois and southern Wisconsin, saturating the ground and swelling rivers. Dozens of water rescues were conducted in Chicago and Milwaukee as streets flooded. Communities were already waterlogged, already exhausted, already cleaning up, when meteorologists began, issuing warnings about what Friday, April 17th was going to look like. And what April 17th looked like was the worst day of the week, by far. April 17th, 2026, will be remembered as a historic day in Midwest severe weather history. Here is exactly what happened. At approximately 1 in the afternoon, the first supercell thunderstorms began firing along the cold front in southeastern Minnesota. The atmosphere was primed, the shear was exceptional, the moisture was rich, and the cap, the layer of warm air that normally suppresses storm development until conditions are perfect, broke all at once. When the cap breaks, storms do not form one at a time. They explode simultaneously across a wide area. At 2:17 p.m. local time, the first confirmed tornado of the day touched down just northeast of Stewartville, Minnesota. This was an EF2 with estimated peak winds of 130 miles per hour. It tracked 9.7 miles over 14 minutes through Stewartville and Marion townships, damaging numerous homes and farms. Near Marion Road, northeast of Highway 52, the worst damage was documented. Roofs removed entirely, exterior walls partially collapsed. 2 people were injured. Over the next several hours, the outbreak spread rapidly eastward. Tornadoes touched down in Olmsted County, Wabasha County, Buffalo County, Marathon County, Winnebago County, a geographic swath that stretched from southeastern Minnesota through western Wisconsin and into northern Illinois. By 5 p.m., the National Weather Service was tracking active tornado signatures across multiple states simultaneously. In Marathon County, Wisconsin, the town of Ringel, population 1,700, took a direct hit. Approximately 75 homes sustained damage as a tornado moved through, reportedly trapping some residents in their basements. Fire Chief Chris Kielman reported that several homes had been completely demolished. No one died, a near miracle given the scale of the destruction, but displaced residents were evacuated to a nearby middle school as emergency crews swept through the debris. In Buffalo County, Wisconsin, aerial imagery captured by news helicopters showed a scene of apocalyptic devastation. Homes leveled to their foundations, barns reduced to splinters, trees stripped bare. The National Weather Service confirmed an EF3 rating for the tornado that hit this area, meaning winds of at least 136 miles per hour, capable of destroying well-constructed frame homes. In Lena, Illinois, a village in Stevenson County in the northwestern corner of the state, a large and powerful EF2 tornado caused widespread damage to homes and businesses, scattering debris across the entire community. The Stevenson County Sheriff's Office asked the public to avoid the town entirely while emergency crews worked. Near Rochester, Minnesota, a tornado was captured on a traffic camera. A haunting image of a dark funnel descending from green-tinged clouds while cars on a Minnesota highway pulled to the side of the road. 30 homes in the Marion area alone reported damage. A semi-truck driver near Howard, Iowa, was forced into a ditch when his vehicle was struck by tornado-force winds, the outbreak's first reported injury. By the time the storms moved east and began to weaken Friday evening, the Storm Prediction Center had received reports of 53 tornadoes across 6 states on April 17th alone. The NWS La Crosse office had issued 26 tornado warnings, a record for that office in a single day, and the damage assessment teams had not even begun their full surveys yet. In the aftermath of any major weather event, the numbers are what transform a news story into history, and the numbers from the April 2026 Midwest outbreak are staggering. In total, the multi-day severe weather event from April 13th through April 19th produced at least 46 confirmed tornadoes in the Chicago NWS forecast area alone, and that number is expected to rise as survey teams continue their work. The NWS Chicago office has confirmed at least 20 tornadoes within its specific forecast area, which is roughly equal to the typical total for an entire calendar year. In less than 1 week, the region experienced a full year's worth of tornado activity. The hail reports were extraordinary. Over 120 reports of large hail were recorded during the 24-hour stretch between April 17th and 18th. Near Kankakee, Illinois, hailstones measuring 5 to 6 inches in diameter were reported. Hailstones roughly the size of a softball or a grapefruit. If confirmed, these would shatter the existing Illinois state record of 4.75-inch hail. For context, a 5-inch hailstone weighs approximately 1 pound and falls at speeds over 100 miles per hour. These are not weather events, they're projectiles. Wind damage was equally severe. Measured wind gusts of 60 to 70 miles per hour were widespread across the region, with some areas recording gusts above 90 miles per hour. Power outages affected more than 50,000 homes and businesses across Illinois, Indiana, Missouri, and Oklahoma on Saturday morning alone. Rainfall totals across northern Illinois and southern Wisconsin reached 4 to 6 inches in many locations over the course of the week, on top of ground that was already saturated from earlier storms. Rivers rose rapidly. Flood watches were issued from Missouri to northern Michigan. In Chicago and Milwaukee, water rescue teams responded to dozens of calls as streets became rivers. And then there was the death toll. Across the entire 2026 tornado season to date, 11 tornado-related deaths have been confirmed in the United States. 3 of those deaths occurred in the EF3 tornado that struck from Kankakee, Illinois to Lake Village, Indiana, a tornado that also dropped the potentially record-breaking hailstones. 1 fatality was caused by lightning in Waukesha, Wisconsin during the storms on April 15th. The fact that the April 17th outbreak itself, despite producing over 50 confirmed tornadoes and catastrophic damage, did not result in additional direct fatalities speaks to the effectiveness of modern warning systems. The average lead time for tornado warnings in the United States is now approximately 13 minutes, enough time for people to reach shelter if they act immediately. On April 17th, that warning infrastructure worked. This is the question that goes beyond the immediate disaster. Why is 2026 already shaping up to be one of the most active severe weather seasons in recent American history? And why is it happening so early in the year? The NWS Chicago Forecast Office has described 2026 as having a very active start to the severe weather season, a remarkable understatement. From January 1st through April 19th, the Storm Prediction Center had already placed at least part of the Chicago forecast area under a severe weather outlook on 15 separate days. The average for that same period is approximately 4 days. That is nearly 4 times the normal rate. The answer involves 2 intersecting factors: natural atmospheric variability and the long-term trend of a warming climate pushing severe weather season earlier and further north. On the natural side, 2026's early season outbreak pattern reflects an unusually strong and active jet stream that has repeatedly tapped into Gulf of Mexico moisture at times of year when the atmosphere is not typically primed for severe weather. The corridor from eastern Iowa into southern Wisconsin and northern Illinois has been particularly active. Meteorologists describe it as a hotspot for severe weather in 2026, with a dense concentration of tornadoes, damaging winds, and large hail concentrated in this specific region. On the climate side, a well-documented shift is underway. Over the past 2 decades, tornado activity has been migrating eastward, away from the traditional tornado alley of Kansas, Oklahoma, and Texas, and into what scientists now call Dixie Alley, a corridor running through Arkansas, Mississippi, Alabama, and Tennessee. But the 2026 events show that the upper Midwest is also seeing unprecedented activity. The population density in these newly active regions is higher than in traditional Tornado Alley, and storms in the Great Lakes region often strike at night when people are asleep and less likely to receive and respond to warnings. AccuWeather meteorologist Alex Duffus warned earlier in the season that while total tornado counts might be near the 30-year average, the severity of individual events could be significantly above normal, with a particular concern about damaging winds and flash flooding. That prediction has proven accurate. The focus now shifts to the May and June peak of tornado season, when the atmospheric ingredients that drove this week's outbreak will be even more potent. Throughout this story, you have heard terms like EF2 and EF3. But what do those ratings actually mean in human terms? What does it feel like to be in the path of a tornado rated at these levels? And how does the damage from this week compare to the most extreme events on record? The enhanced Fujita scale, the EF scale, rates tornadoes from EF0 to EF5 based on the damage they produce. An EF0 has winds of 65 to 85 miles per hour and can snap branches and damage roofs. An EF1, at 86 to 110 miles per hour, can peel roofs off homes and flip mobile homes. An EF2, like the tornado that struck Stewartville and Marion in Minnesota, has winds of 111 to 135 miles per hour, strong enough to demolish poorly constructed homes, uproot large trees, and flip freight trains. An EF3, like the tornado confirmed near Cream, Wisconsin, carries winds of 136 to 165 miles per hour, sufficient to level entire stories off well-built homes and throw vehicles hundreds of yards. Above EF3, the scale reaches EF4 and EF5, the latter theoretically unlimited in wind speed, with the most powerful ever measured estimated above 300 miles per hour. Between 2013 and 2025, not a single EF5 tornado was confirmed in the United States, a 12-year gap that was the longest on record. That drought ended in June 2025, when an EF5 struck Enderlin, North Dakota, killing 3 people with estimated winds above 210 miles per hour. The tornadoes from this week's outbreak, predominantly EF2 and EF3, were powerful enough to cause catastrophic structural damage. The EF3 that hit Kankakee, Illinois earlier in the week destroyed over 500 buildings, killing 3 people and crossing into Indiana before finally dissipating. An EF3 tornado at 140 miles per hour is not a weather event you survive through luck. You survive it by being underground. This is why meteorologists, emergency managers, and storm chasers all say the same thing every year, without fail. When a tornado warning is issued for your area, you go to the E, lowest level of your home, to an interior room away from windows, and you do not wait to see it with your own eyes before acting. The storms this week moved at speeds of up to 60 miles per hour across the ground. By the time you can see a tornado, you may have seconds, not minutes, to find shelter. Numbers tell the scale of a disaster, but it is the human stories that tell its weight. In Ringgold, Wisconsin, Fire Chief Chris Kielman stood in the wreckage of his town on Friday evening and described what his crews had found. Homes demolished, families in basements, some of them unable to get out on their own, debris scattered across streets and fields. His crews went door to door, property to property, checking each site to ensure no one was trapped. Several homes, he said, had been completely demolished. And yet, somehow, not one person in Ringgold died that night. In Rochester, Minnesota, residents described the experience of watching a tornado through their windows before diving into their basements. One local resident told CBS Minnesota that she had watched the funnel move toward her neighborhood before her husband pulled her downstairs. When they emerged, 3 houses on their street had lost roofs. Their own home, by a matter of geometry and fortune, was largely untouched. In Belton, Missouri, a police chief stood at a press conference surrounded by downed trees, ripped siding, and damaged power lines. He described the damage as widespread, but, like the police chief in Ringgold, he credited the city's preparations before the storm with helping people get to safety. The warnings worked, he said simply. No deaths, no serious injuries, just destruction that would take months and millions of dollars to repair. Perhaps the most dramatic footage came from Fox Weather storm trackers, Brandon Kopic and Corey Gherkin, who were pursuing a confirmed tornado near Rockton, Illinois on Friday afternoon when debris began raining down on their vehicle. Their footage, trees snapping, power lines arcing, debris filling the air, showed the terrifying reality of what 90 miles per hour winds actually look like from a few hundred yards away. And then there was the traffic camera footage from Rochester. A simple, grainy overhead shot of a Minnesota highway, cars pulled to the shoulder, and a dark wedge funnel hanging from the clouds above them like something from a nightmare. That image, shared millions of times on social media, became the defining visual of the outbreak. A reminder that tornadoes are not abstract weather events. They are real, they are sudden, and they are coming whether you are ready or not. The central United States got its first real break from severe weather on Sunday, April 20th, as the Storm Prediction Center's outlook for that day showed no areas at elevated risk. But meteorologists are emphatic. This is a pause, not an end. The peak of tornado season in the United States runs from May through June for the Central Plains, Kansas, Oklahoma, Nebraska, and Texas, and from March through May for the Southeast. For the upper Midwest and Great Lakes, peak activity typically does not arrive until June and July, which means the regions that were hit hardest this week are, in calendar terms, not even at their most dangerous period yet. The 2026 season's unusual early activity in the Great Lakes corridor has forecasters paying close attention. The atmospheric pattern that produced the April outbreaks, a highly active jet stream repeatedly tapping Gulf moisture earlier than typical, shows no signs of fundamentally changing. As summer approaches and the moisture supply from the Gulf increases, the ingredients for severe weather will become even more potent. There are also ongoing concerns about flooding. The ground across northern Illinois, southern Wisconsin, and parts of Minnesota is deeply saturated after weeks of above-normal rainfall. Rivers in several areas are running at or near flood stage. Any additional significant rainfall, which severe thunderstorms routinely produce, risks pushing those rivers over their banks into communities that are already struggling. And there is the longer-term concern about infrastructure. 50,000 homes and businesses lost power during this outbreak. Power grids across the Midwest are aging, and repeated severe weather events stress them beyond their design tolerances. Emergency managers in Illinois, Wisconsin, and Minnesota are already calling for reviews of shelter availability, warning system, coverage, and storm hardening of critical infrastructure before the next outbreak arrives. Because the next outbreak will arrive. That is not pessimism, it is meteorology. The question is not whether another significant severe weather event will hit the central United States this spring. The question is how prepared communities will be when it does. This week's storms took a serious turn. They confirmed what weather scientists have been saying for years, that the United States is entering a period of more frequent, more intense, and more geographically widespread severe weather. The April 2026 outbreak was not a freak event. It was a data point in a trend. But this week also showed something else, something worth holding on to in the middle of the destruction and the grief and the exhaustion. In town after town, Ringel, Belton, Rochester, Lena, communities responded. Neighbors helped neighbors dig out of debris. Emergency crews worked through the night. Warning systems gave people the minutes they needed to get underground. And despite the devastation, the death toll was a fraction of what it could have been. Nature at its most violent is humbling. But human preparation, human coordination, and human resilience, those are humbling too, in a completely different way. Stay weather aware. Know your shelter location. Have a plan. Because this is not the last time the sky will turn green. If this video helped you understand what happened this week, please like it, share it with someone in the storm-affected region, and subscribe for more in-depth weather and science coverage. And drop a comment. Were you impacted by this week's storms? Tell me what you experienced. I will see you in the next one. Stay safe out there.